today we'll be talking about the physics of a golf swing,
which includes moment of inertia, energy, torque, and the Magnus effect.
The moment of inertia is determined by the equation 1/3 mass of the shaft times the length of the shaft squared plus the mass of the head times the total length squared. Our total MOI was 0.34615 kilogram meters squared.
When examining both the swing and the hit of a golf ball, you have to assess the energy calculations for both the swing and the hit. There's linear kinetic energy and there's rotational kinetic energy, both of which get transferred into the golf ball after the hit. Thus, you see a decrease in both of them in this graph. There's also energy that gets dissipated into the system, which gets approximated using the coefficient of restitution, which is approximately 0.83. Thus, 17% of the energy gets dissipated into the system. The torque of a golf swing. The torque of a golf swing is found by finding the centripetal acceleration, which will then be used to find the centripetal force, which can then be used to find the torque. The centripetal acceleration is omega squared divided by the radius of the club, which is then multiplied times the mass in order to find the centripetal force, which that centripetal force can then be multiplied times the overall radius in order to find the torque.
Backspin on a golf ball causes a vertical force that counteracts the weight of the ball and allows the ball to remain airborne a little longer than would be the case if the ball were not spinning. This is known as Magnus effect. Clockwise spin around the ball's vertical axis causes slices, whereas counterclockwise spin causes hooks.
What I try to do, I try to flat load my feet so I can snap load my power package. That way I can amplify both lag and drag pressure through impact fix. As long as my number 2 power accumulator doesn't break down, I can reach maximum centripetal force with minimum pivotal resistance. You see, the pivot is the utilization of multiple centers to produce a circular motion for generating centripetal force on an adjusted plane, plus maintenance and balance necessary to build a 2-line delivery path. See, golf is geometrically oriented linear force. It involves a physical muscular thrust and a geometry of the circle. You can divide the golf swing into 24 basic components, each having between 12 and 15 variations. Now, when you think of all this and you get it all set, hopefully you'll hit shots like this.